Today what we are going to be talking about is about one of the repositories that we started in this GitHub repository initiative, which is about Terraform. So I will explain you all the different modules that we've developed. I will also give you an overview about what Terraform is if you are a newbie in this field. We will try to get hands-on on them, and also I would like to show you some of the tools for the Terraform ecosystem that facilitate us the work and the development of the different modules. So let me start sharing my screen. Can anyone confirm if the audio is working? Just to make sure that I'm not just talking without audio or anything. Perfect. Thank you very much. Okay. So Terraform templates, as I was saying, I'll be giving a quick overview of the GitHub initiative. I will show you which is the approach for these Terraform templates and for whom it is intended to use. We can also discuss about the maturity path that these Terraform templates can have, and also some requirements that you may need to have installed in your laptop. I will explain you. I will give you a quick overview of what Terraform is, how does it work, and so on. And we'll go through the different templates. Also, as I said, I will explain the different tools, because there are some that for Visual Studio Code and so on are pretty handy. So let's go. The GitHub initiative. Well, to give you a little bit of context, this is something that we've been working since more than a year ago at ERNI, and we made or went live during summer. During these 2 years, we've been working in more than 20 repositories where we are publishing starter kits, asset guidelines, POCs in any of the fields that we have experienced at ERNI, like cybersecurity, Q&A, cloud, DevOps, backend, and other technologies. So you can find along the different repositories a QA automation framework, which is developed in .NET 6, Terraform templates, which is the ones we are gonna be showing today, Ansible playbooks, Azure DevOps templates also for the pipelines, a framework to automatize pen testing, mobile templates, cloud accelerators, and virtual reality games. So if you go to our organization at GitHub, you have a description of why are we doing open source at ERNI. You will be able to find here in the README also the latest videos that we've uploaded to YouTube, and also you will find in our Eventbrite channel which are the upcoming events that are gonna be taking place in the upcoming weeks. So for the newcomers, what I encourage to do is to visit this awesome resources repository where we are gathering all the different knowledge that we are generating here, like trainings, backend assets, front-end assets, mobile, quality assurance, cloud, cybersecurity, DevOps, and GitHub Actions, and well, upcoming things like embedded stuff and so on and so forth. So as the community word stands, this is something that we don't believe it's a one shot, and this is something that we want to generate community to contribute, not just people from ERNI, which are the main contributors currently, but we want to encourage also that people from outside, if they find the repositories useful and they would like to use them for their own purposes or whatever, to contribute to them, to create issues, to create pull requests, or whatever they believe might be interesting. Okay, so let's go. How about Terraform? For whom is this approach? Well, the Terraform templates that we've generated are modules that as they are right now in the repository, you can run with 3 or 4 single commands. So it's in my opinion, it's something useful for people who haven't used Terraform and want to start in few steps. So you will see that with 3 or 4 commands, you will be able to generate your infrastructure in the cloud. For projects that might need a quick infrastructure setup, so you don't need to go to the portal and to the cloud provider to generate resources by hand. For teams with the you build it, you run it mindset, which is this mindset in where the development team is also taking kind of responsibilities of this operational part, and also for projects who are or might be having configuration drifts between different environments and that would like to give persistence to the infrastructure using this approach. Okay, so what do you need as an initial requirement before running the repository? You will need an Azure subscription, otherwise you won't have a space where to deploy it. And well, Azure has a free space that you can register, and I think if you come here, you might need to find out. Yes, here. If you open this link, you will be able to register yourself to get a free trial account with $2,000 credit, and you will be able to run any of the different repositories that we have listed here. So apart from the subscription that you will need to register before, you will also need to install Azure command line interface. So this will be the tool that will allow you to connect to the Azure subscription itself, and then of course Terraform, who is the tool that I will give you a bit more context of what it is, that allows you to codify all this infrastructure. Okay, so okay, what is Terraform? Does anyone in the chat is completely newbie in this topic and haven't ever heard from it? Because if that's the case, let me know and I can give you a little bit more higher overview context. If that's not the case and you already know what Terraform is, it's a infrastructure as code tool, allows you to codify all the different cloud resources that you will need to deploy, and where you will need to deploy your work and your projects, like even if it's code, databases, or any PaaS solution you would like to deploy. And the main benefits of using Terraform is that you write it once and you can deploy it in as many let's say subscriptions or places where you would like to. It also serves as disaster recovery, because anytime your infrastructure can get down, just with 3 single clicks, you can get it back. One of the things that I like the most is that you will have the ability to manage your infrastructure from a transactional system like is Git. So every change or every configuration change that you do to your infrastructure is logged and tracked. So you will have the audit log of every change that happens in your infrastructure, and also because it can be used for ephemeral environments. Let's say that you need to create an environment in where to run some random tests at some point. You will be able to do it really quick, easily, and with few single clicks. So it's pretty handy in this regard. As I was saying, here in the repository that we're working, we have developed different modules, which the way they are developed here it's done on a way that you can go to the samples, run 3 single commands, and put it back on the cloud, which might be the the next steps. Well, of course, the goal is to not have these standalone resources in a single repository, but that you have a collaborative workspace in where everyone who might be responsible of managing this infrastructure work together with you, and the infrastructure is deployed automatically using pipelines. So the goal is that I will show you also after which are the tools of this ecosystem that will give you visibility on the cost of the infrastructure and vulnerabilities that may be happening. But the goal is to have kind of a golden path in where you can develop this end-to-end solution. So let's get hands on it. I will start deploying any of the solution. Well, I will describe first which are the ones that we have available. We have an Azure Kubernetes service. We have an Azure Kubernetes service with a container registry in the case that, well, you don't have it available and you are starting it from the scratch, and as you will need a container registry, this bundle can help also on accelerating things up. You also have a Linux web app and Windows web app, which are the former app services that now it has been changed from the Terraform provider. You also have functions, Servicebus queues, Servicebus topics and subscription, and Sonarqube. With Sonarqube solution, we can get hands on it, but we have two. One approach follows the infrastructure as a code. It uses an infrastructure as a code PaaS solution, and the other one it's under development and well, it's not fully finished because it has some bugs and issues that you can have a look here, but it's under development. So, well, I will openly ask you if any of you has interest in any specific resource, we can get on it. Well, what I can show you also is the development environment. Okay, so there are two useful things, or three, that I would like to tackle. The first one is Chekhov. With Chekhov, it's a tool that monitors the different vulnerabilities that you might be having in your infrastructure. So as you can see, here I can trigger it to the AKS module, and you will see the different vulnerabilities and how to fix them. Okay. The other one that is really interesting is the infracost one. And with this one, it's really interesting because you will be able to monitor which is the expected cost of your infrastructure. So, for example, if I go to the sample, I think if I come here and open this AKS sample, we have this pool size, which is the standard D2. But if I modify it to the D3, which is a more powerful one, the infra cost will calculate the increase of the cost. I take a little bit. Okay, as you see, it's almost the double of the price. So we can keep it this way. Okay, so well, this is mostly the structure of the repository, and as I was saying, we can go and deploy, for example, this AKA sample. So to deploy this, as it stands also in the documentation, you need to do the AC login and AC account set, which I've already done. So I don't have to do it right now in my Visual Studio Code because I was this morning managing already. So what you need to do is you need to browse to AKS, okay, samples and AKS, And here, what you need to do is the first steps of the Terraform triad, which is the init, the plan, and the apply. The validate, well, might be useful if you want to validate the configuration, but it's not needed. So, well, maybe I'm going way too quick, but as for deploying it, it takes some time. I'm expecting to deploy it, get it running, and then in the meantime, I will explain you what's a module and how it's been deployed. Okay, so let's go for it quick. The first thing is Terraform init, in which this command, what it does, it's download the different providers that we have. Terraform by default, it has providers for Azure, for Amazon Web Services, and for many other vendors, in where you just need to download the provider itself, and it provides a lot of functionality. So for example, inside the provider, there are hundreds of resources created. So if we go to the Terraform documentation, you will see that if I search for Azure RM, okay, I will do it the easy way. As you can see, in this provider, you have like tons of different modules. So for example, the first one that we are using, which is the resource group, where to put everything, is documented here. And you can see an example usage and the different arguments that are required or optional. Okay, so what it does, it downloads everything, so that this every time I import these resources to the Terraform file, it works. And when this init has been done, everything has been downloaded and put it here in some folder inside, you know, the modules and the providers. And then what I will do is to run the plan. With the plan, what Terraform does, it simulates running this command over the cloud. It checks everything. It automatically also validates, which is like part of this command, and then it will ensure that you don't have any errors in your configuration, and that the next step that you need to perform, which is the apply, works properly. So let's wait for this to work. What it does also is to it generates a TF state. Well, as you can see here, what it does is it's show you the different actions that are going to be happening. Okay, so I will directly apply. With this auto approve, what I do is well, avoiding to prompt this yes thing that I need to write. And if you can see, as soon as I run this Terraform apply or plan, what it does, it creates a TF state file. Why this TF state file is so important? Because now, as I said, we are working on let's say a standalone mode, in where from local to the cloud and deploying the resources. But if at some point you want to automatize this into a pipeline, the Terraform TF state file is the file that Terraform needs to ensure, or to let's say, to monitor the different changes that are taking place in your infrastructure. So to avoid configuration drifts, if you do not include this Terraform TF state in your pipeline or in an automatized process, there might be a chance that every time you run this template, everything will get broken, because it will not recognize which assets are already deployed into the cloud, or within this configuration into the space that you have used. Okay, so well, to sum up, What it does is generates a resource group, which is the KS sample in location West Europe with the tag demo. And then what I do is importing a module. And what is a module? Well, I'll try to explain quick. A module, it's a way that Terraform, it's a standard way of Terraform to reuse components. So typically, I think it was several years ago when Terraform was starting, all the infrastructure had to be codified in a way that, well, you had this main file in where you define everything, you define the output, you define variables, and you define the different versions. But the problem here is that when creating this or when having different similar environments like staging or production, you had to develop the same code many times but with different variables, which was not pretty convenient, and it wasn't really applying these dry patterns. So with these modules, what you can do is extract these variables as by using internal variables and importing these importing them to this module so that I use it as a source, and the different environment variables are defined in this implementation. So it's way much more straightforward. It kind of works as a, let's say, configuration file. Okay, so well, this is being deployed. We can go to the portal to see how is this going. And here in the portal, we see that the resource is already created and that we have the Kubernetes service, but probably we'll need to wait it for the end of the deployment. Okay. Okay. More things. Well, whenever you start developing also with Terraform, you will see that the indentation gets a little bit dirty. So every time, for example, I declare here a new variable, it doesn't get indented properly. And one of the things that I find really handy is that Terraform has a command which is Terraform FMT, and this will automatically auto-indent it. Wait, I'm not in the right folder, sorry. Okay, so if I run it now, okay. Okay, demo effect. Let me try this way, because I've been using it today quite a few. Maybe it's not the right command. Yeah, there it goes. So as you see, it auto indentates all the code. So this is pretty handy when you are modifying variables and at some point you want it to indentate it automatically. You can do it this way. Another really handy tool that I find really useful is Terraform docs, in where every time I get into or I develop a sample or a module itself, if I run this Terraform docs markdown and I specify the folder, so for example like this, it will generate me the automatic documentation on the sample itself, which I haven't used yet, but the first one that I used for it was this one, and to me it was really useful, so that I have all the resources listed and I have all the inputs, and also you can list the different outputs that the module will have. Okay, So let's see if this has finished. Okay, so apparently this is already working, and well, I must admit that I haven't tried to deploy anything yet, but I'm pretty sure this is already in place. And if you haven't ever worked with Kubernetes, I encourage you to try Helm or any other provider for deployment, so that you can deploy containers in clusters like pretty easily. Well, so this is mainly it. As I can imagine that this is not really something that you can work with, I will destroy the resource with this command. And what I'm gonna do is I will deploy the Sonarqube instance, because I believe, well, oh sorry, I just I made this change, which is preventing me to. Okay, so what I will do is I will deploy the Sonarqube instance. I will explain you which are the different modules that it has inside, and well, at least it will be something in which we can enter and we can interact with. Okay. So, well, for the Sonarqube module, that I believe it might be something that could be useful for you. Let's say if you're starting a new project and you would like to have this Sonarqube in place for analyzing vulnerabilities or for doing branch analysis and so on and so forth, you can deploy it in a single VM, and with single steps also, as I'm gonna show you. The only thing that I would like to mention in regards this Sonarqube thing is that you will need to generate a PEM file, and you will need to place it here under the Sonarqube IaaS resource, because this will be like the key that will allow you to enter to the machine. This is something that I must admit also that I haven't worked much on fixing vulnerabilities, but for a quick test, it will work, and it will help you to do and to run some tests on it. So I will wait for this to be finally destroyed, or well, maybe I can create. Yeah, I will do it on a different terminal. So, any questions so far, or maybe I'm going so fast? To me, it's a bit weird to be talking without interacting to anybody. So let me know if there is something that is not clear, or something you would like me to dig in a little bit more, and I will be really glad to explain you. So if not, I will go to this sample, Sonarqube IaaS sample. Okay, well, you can address it right now. I mean, this is not, I don't have a dedicated space for the questions, so feel free to send any over the chat, and we can try it live. So the Sonarqube example, I will do the same as before, which is the initialize step. Okay, yes, about the Terraform state. So tell me more. Yeah. I know the struggle. It's difficult to manage, especially which is the issue that you've faced mostly? Because to me, one of the tricky things was to modify the TF state, or to have the permissions on the pipeline to modify the TF state in the provider where you have the okay, trying to manage different environments at the same time. Okay, well, in this case, it will be interesting to get to know how do you have your ecosystem. But for example, let's make a, yeah, you need to be really careful. So typically, what I suggest when working with different environments is that when having Terraform, you can have this modules folder first, and what I suggest to have is to have the different environments in different folders. So for example, if you have a DevOps environment where you can have this Sonarqube, Bolt, or configuration management tool, then you can have the QA environment where to have the different implementations, like, I don't know, you can have here an AKS, or you can have a database implementation, and the same for staging, AKS, DB, and the same for prod, AKS, DB. So every time you have this if you have this taxonomy in the repository where you have all the Terraform files, whenever you are running it in the pipeline, you can explicitly set, let's say, environment variables, or you can map the naming of the branches with the different folders, so that you have different TF states for the different environments that you have. I don't know if this is something that you have already implemented in your project, or you had it all together in a single place. But well, from my previous experience, this kind of worked or helped us to bypass this situation, so that inside the place where we were managing these TF states, we had this categorization, and it was easier to manage. I don't know if this helps. Let me know. I'll be reading you. So after this, well, we'll need to do again the Terraform plan. But yeah, I know that this TF state management, when trying to or to automatize the process into the pipeline and have your infrastructure repository secure, will be tricky, because you will need to have access from the pipeline to this resourcing where you're putting the TF state and the permissions and so on and so forth. Okay, and let's apply it now. So as I was saying, now I'm deploying it in a single virtual machine, which is probably not the most secure thing. We are deploying a resource group, a virtual network, a sub network. We are creating the public IP, the network security group, and all the different resources that are needed. And what we are working on also is to have it in a platform as a service solution. And by that I mean, wait a second. The plan is that we create a resource group. We can put this Sonarqube instance into an app service, which is, let's say, more secure, more convenient, and needs less configuration. And that you create the storage account for putting all the information of this Sonarqube instance in a SQL server. Okay, so this is not fully ruled out, because we are having let's say an issue when creating the Sonarqube instance, because, well, you will need to generate different resources or storages for the configuration of Sonarqube, and at some point there is a step in where we need to upload this profile to one of the resources, and we couldn't find yet a way to make it automatically. So if you are experienced with this and willing to to give us a hand in these regards, let us know, because well, we also have an issue created in the repository, so that it will be interesting, or at least we'll be trying to focus on it. But well, mainly what this is, it's a Docker Compose with the Sonarqube 8.9 with extensions for being able to analyze also branches, and well, we will see it afterwards. Some other things that I wanted to show you in the repository, for example, is what we have in the pull requests. So we have several plugins here, like Breathe Crew, which is in the end this checkoff, which what it does is it does analyze the vulnerabilities of the different issues that might be happening in the repository. So as you can see, this infrastructure as a service Sonarqube solution has a lot, and it's very handy because it also gives you a how to fix approach, and also from the Visual Studio Code you can manage to fix them. Like, like here, I think, yeah, just give me a second. You can apply the quick fix, which, well, it's helpful, let's say. Another thing that I wanted to show you here is that apart from this Breathe Crew integration that we have the Sonarqube integration and the InfraCost integration, so that every time you make a change into your infrastructure repository, it will let you know which will be the increase of the pricing per month. Okay, so this is pretty handy also if you have Kubernetes cluster, for example, not so much for pay-as-you-go services like app services or functions, because this will not be monitored, but at least for the static pricing, it will be really useful. And yeah, well, apart from that, we also have integrated this Sonarqube analysis, where you can see the different vulnerabilities and security hotspots. So yeah, there are many that we will need to address. We are monitoring it here as issues, but we'll need to work on it a little bit. So let's see how this deployment going. Okay, seems that it's done. So what we can do is we can go to the portal again. We'll go to the resource group we have created, and here we have the DNS name, and we have a Sonarqube instance already deployed. As you can see, it's not secured. We have the admin password as initial, but as I was saying, for testing purposes, if your project is not open source, you don't have Sonar Cloud, or you don't have the ability to or you don't want to pay the licensing, you can have this instance and you can integrate it with your pipeline. I have already a video, or there is a video in our YouTube channel where I explain how can you integrate with a Sonarqube instance your Azure DevOps repository or any other. So I think I will paste you in. If you are interested, you can find it in our ERNI Academy, in our YouTube channel. So I think it's somewhere here. Here. So you will be able to follow all the steps, and well, my plan also is to update the documentation to the repository so that you can follow yourself. Yeah, well, now to destroy it as the same as before. Terraform destroy, and it will remove everything. So you also have available this I will try, maybe I have time to deploy yet another one like the Linux web app. So if I go to samples, go to Linux web app sample, and I do the same, Terraform init, Terraform plan, and then they apply. You will have it working. So we have 13 minutes left, and well, I'm not sure if you have any more other questions, or does any of you believe this can be useful for the day-to-day basis, or are they willing to use it, just for testing purposes or whatever? Or questions in regard the tools, in regards the plugins that I'm using for security, for calculating the costs, or whatever. I don't know if the chat has some lag, or maybe I'm bothering too much. Okay, so if there aren't any other questions, maybe I will show this. It's available in our GitHub repository. I will paste it in the chat because it's here in ERNI Academy, and then you have this IAC, Infrastructure as Code repository, that I will paste here. And there you can clone the repo, you can fork it, you can contribute it, you can whatever you believe might be useful for you. You can do it. So let's wait for this Linux web app to be deployed. Just to give you a short summary also of what it does. This generates also an application insights for all the logging, which is binded. It also generates the service plan for the pricing, and then the web app itself. So this specifically, it's done for .NET, but of course, if you're using any other stack, you just need to follow the documentation, and below this application stack, you can modify the .NET version, Python version, or whatever you would like to to have your Linux root app prepared will be set up. So now we go again to the portal. And if we go to the resource group, we have created this resource group with this app service. And I think that it should be reachable now. Okay, so the web app is running now. Is on your desk to put the application inside and deploy it however you want. I think with this new I haven't tested yet, but with this new Linux thing, I forgot which is the name. Well, Terraform it's to me, I would recommend it to use it in any case that you are developing cloud solutions. Probably there are things and tools also that, for example, I will show you this Terracognita, that what it does is that whenever you have already started in the cloud and you have many resources deployed in the cloud, it's a reverse Terraform. And what it does, it connects to your cloud, it gets to know which are the resources that you have already deployed there, and what it does, it generates all the Terraform files of the infrastructure that you already had in place. So this is really useful for those who already started but didn't know about Terraform, that wants to start using this infrastructure as code paradigm and get their infrastructure monitored from an audit log and a transactional system like Git. So to me, anyone who is using either Azure or Amazon Web Services should be using Terraform. But that's my opinion. Either Terraform or any infrastructure as a code tool. And one of the things that I was saying about this, you're welcome, about this Linux web app is that I believe that from scratch you can specify the container, and with the container no. Yes, you can have a Docker block inside not the out settings, but the well, it's a standard Docker block in where you can specify the registry, the name, and the tag, and the username or password or whatever, and it will automatically generates you the Linux app service with the Docker inside running. So I haven't tested yet, but I believe it's really handy, because, well, this will prevent you from doing a lot of steps for deploying your Docker container to your function app and so on and so forth. So, well, that's all that I wanted to show you. Thank you very much for all the attendees, for the interest and for all the questions that you've been sending along the chat. We have 6 minutes left. If you have any other question in regards the repository itself, or anything that I've been explaining, like this tooling that I'm using for the development and so on, let me know. If not, well, you have our social networks here. You can send us an email, you can rate us on Twitter, or you can even create issues or pull requests to the repositories, so that we can be in touch. So, well, that's it. Thank you very much for all the attendance, and looking forward to see you soon. Bye bye.